a very wonderful job. So,
So,
um,
Abigail, you have a message
I would
from
say this before
one of your
we
film
commence.
friends. My name is
I've
Precious.
mentioned it
Sorry,
previously.
sir. Please, can the host mute
Yes, one
everybody,
of your
please?
friends.
Please, can the host mute everybody, please? There's a lot of disturbance in the background.
Could you yes?
Okay, I
Oh,
believe
I'm
the
calling
host,
you
the
from the
co-host are
NYC
here, so
orientation camp,
he's going to
and
mute
then
every other person on the call.
God, I beg. Okay, so Begulia says, "Happy birthday to you, my darling." How did you know she was the one that like he was so direct?
Please, what's going on? That person should mute himself or herself now.
Hello, please, can that person mute their call, please? All right. So the PLC programming section is going to be in two phases. We would have the Siemens programming parts. Then later on, we would go through Rockwell Automation, that's Allen Bradley PLCs. So we all know that in PLC programming, we have several brands. In fact, I think we should have more than hundreds of PLC brands. And depending on which region of the world you are, depending on the industry you play on, you will come across different types of PLC. And I can assure you that what you need to know is the basic principle, the first principle of how the PLC works, how it functions. As we go along with the course, this class would be introduced to all these basics that is needed. The purpose of splitting the PLC programming into two, one for Siemens and one for Rockwell, is because those are the major brands that you get to work with. And so, can this person please mute his call?
Please, can you mute everyone's call? Thank you.
Okay. So, for the programming part, I'll be taking introductory class today. My colleagues, that's Olaoye Abubakar and Ulysses Olamilekan, will take the other parts of the Siemens programming, while I will come back and take Rockwell Automation. Oh, I was muted. Okay. So my colleagues will take the other sections while I would come back and take Rockwell PLC programming. Earlier this week, I shared a Google Drive link for us to download the software for Allen Bradley PLC. So I have Studio 5000 on that drive. And if you see, there are two links. The reason why we have two links is one of those links, I think when you run it, you would install Logix Designer, while the other one will install View Designer. So just the way we have TIA Portal, where you can have your HMI and your PLC designed from TIA Portal, Studio 5000 is also an integrated software for Allen Bradley system, where you have your PLC design software and your HMI design software all embedded in one app. So you can open any of the one you need from the Studio 5000 interface. But then during installation, you need to make use of the two files. So when you download those files, you run the setup for first one, then run the setup for the second one to have your complete Studio 5000 package installed. Somebody asked earlier, I think today or yesterday, if there is going to be license this thing. No. Rockwell is not a software you pack easily like that. The license is expensive. maybe around $8,000, $10,000, $12,000. But there's a workaround which I think maybe I'll put a pool out when I have about 70 to 80% of people who have downloaded and installed successfully. I would show it's a simple procedure. Just remember there's a way we would extend the trial period. We'll keep extending the trial period until we are done with that. So I would go into the section very quickly. I hope everybody on the call can hear me. If you can hear me, please give me a thumbs up. So for today, we are just going to be talking. Basically, today, the second module will basically be talking. That's all. Before we go into the main sections. When I take PLC classes or when I try to teach or train on PLC classes, I always want to give a background because I've seen that many times when we are trying to learn something, it's very important that we know where or what's brought about these things. When we have that ideology or when we have that information, we are able to build on that. And it forms the basics for us to, because, when you think about your learning in school, we talk about sometimes they tell you before you take this course, you need to understand this prerequisite. You have to pass this prerequisite course for you to take this. So many times you need to have the background of something. So you take like a prerequisite course to know that, okay, this is what I need to know before I move to this point. So today would just be basically uh, introduction. Those of us who have been, maybe you've been working on a PLC before, or you've done something automation related. Majority of what I will say today, you would have heard it before. It might not be new to you, but then we need to understand the nature of this boot camp. There are also people who are joining an automation class for the very first time. Yes, you've seen automation in operation before. You've walked through a banking, you've walked through these doors you have in front of your bank, and you realize that as soon as or a hotel, you get to the front of the door opens by itself because something could see that somebody's in front of it. So, but then what we are doing here is related basically to industrial system. You understand? So it's important that this is properly spelled out. You understand? So the objective of this particular module is that at the end of this class today, if you don't know what industrial automation is about, by the end of this class, we expect that you would know that, okay, this is what we are talking about when they talk about industrial automation. If you've not seen it in application before or something, you should be able to say, okay, think about it. Oh, this is the place I can apply industrial automation to. And then we know that this is basically, can everyone hear me, please? Hello, can everyone hear me? If you can hear me, please give me a thumbs up. Okay, so the role of PLC in manufacturing and process industry. So that's basically what we want to understand. But before I go on, can somebody on the call unmute and just give me, uh, just tell me what do you understand or what do you know about industrial automation? Anybody on the call?
Sorry, anybody that wants to talk will just raise up their hand and now then unmute
Okay,
them,
yes.
please.
If you
Thank you.
want to say something, you can raise up your hand and hear. Okay, Isaiah Elijah. Isaiah Elijah. Lincoln, can you unmute the person? Okay,
I just did that now. I just unmute Isaiah. So I think
okay,
you can talk now.
okay. So can you tell us what industrial automation is about?
Okay, can everyone hear me? Good evening, everyone.
I cannot hear you, Elijah.
Can you hear me now?
No. Can you be a little audible? Are you far from your?
Okay.
Can, can you hear me now?
Yes. Yes, I can hear you.
All right. So, uh, industrial automation, as we say, uh, is is an act or a situation whereby you automate processes. Let's just say in a generic setting where you're supposed to control a light bulb. Let's just say in your household now. I'm just using this scenario to explain how it should be like. So maybe let's just say in your household now, you have a light bulb and you have a switch. That's an open loop control. But in automation, when you automate a system, that system can act on its own based on conditions that are being met. So let's just say now you're in your apartment and you want it to be when you step into the apartment, you want the lights to start, you want the lights to come on. You want everything in your house to come on immediately you step into the house. From there, you now think of integrating a motion sensor and integrating a controller and all that to carry out that particular uh, automation process. So industrial automation in an industrial setting is, let's just say, maybe you have a process, maybe you have a pump that is filling water into a tank, and that tank, you want it to be okay when the water is, let's just say you have a bright beer tank and you want it to be when the beer is, when they've produced the beer and they dosed it into the tank, you want it to be when the tank is full, the pump cuts off. When
Good
the
off.
tank
All
is
right.
low, it doses
Okay.
in beer
Thank
from
you.
another tank. You
Yeah,
can
thank you.
automate
Thank
that
you.
process by having level sensors and all that. So to my own
Oh, okay.
understanding, I believe that's what industrial automation is all about
Okay.
in
Thank
industrial
you.
setting.
Thank you.
Thank you.
That's a good that's a good one. That is a good one. Yes, I can see Caleb and Oyetoro are raising up their hand. So we'll just move forward. I think Elijah did a great one there. So you can just put down your hands. You would get a chance to answer other questions later as the class proceeds. So, what is an industrial process? What is an industrial process? So I would say an industrial process refers to a systematic and controlled sequence of operations designed to transform raw materials into finished products or achieve a specific output. So, oh, sorry. So the thing is this, in industrial process, what do we aim to do, right? We want to produce something. Elijah, please, can you just drop your hands? We want to produce something. We want to achieve a specific outcome. That is, take for instance, you are sorry, please, it's my screen. So take for instance, you are producing say the beer or the drink you Elijah mentioned earlier on. So you know that you are going to bring different things, sorghum or malt, bring water, bring this, bring sugar, bring different ingredients, right? So, but when you are doing these things, you are not just bringing everything into, say, one tank at the same time. Because, take for instance, when you are cooking in your house, you know that at this certain time, I need to put salt. After so amount of time, I need to put Maggi. seasoning. That's seasoning. Because I think there are people who are not Nigerians on the call as well, so they might not know what Maggi is. So say you need to put seasoning, right? So all of these things, they are sequenced, right? They are going to be applied systematically based on the understanding of how the process should go, right? So what we are doing in industrial processes is that basically that all these raw materials, all these raw ingredients, we are bringing them together to achieve one purpose, which is to produce something, right? Which is so you bring your millets, you bring all of these things together, use it to produce, say, Cerelac, use it to produce Godimo, cornflakes, and all of that. That is the specific aspect. That is the outcome of the production. That's the outcome of the process, right? So that is exactly why we say industrial process refers to systematic, right? Systematic and controlled sequence of operations. Because why we say controlled is that when you are producing certain things, you might say, okay, I want this temperature to be within this range, because if it goes beyond that range, my product output can get damaged, or it might not even get damaged, but it will give you something else. So you want this product to taste this particular way, but for you to get that consistency, you need to produce at a temperature of 60 degree. But unfortunately, your system went out of bond and you are producing at a temperature of, say, 80 degrees. And then when the product comes out, it comes burnt, right? So you have not achieved the specification of what you want to get. So basically, that's what we mean by industrial process. Why is my screen? Sorry. Sorry, I'm trying to navigate my screen. How can I? Okay. So we mentioned that I mentioned earlier that industrial process, right? Systematic control sequence of bringing raw materials together to achieve an output. So when we say a controlled system, what exactly do we mean by controlled system, right? So when we are trying to control a process, can you still hear me, everybody, please? Can you still hear me? All right. So if we are trying to control a process, what we are trying to do is that we are trying to run the process within certain boundaries, right? We want that what we are doing, there is checks and balance such that uh, when I want two bulbs to come on, then I have two bulbs coming on, not three bulbs coming on. When I want four bulbs to come on, I have four bulbs coming on, not two bulbs coming on. So the boundaries, like the range within which, or the conditions, like Elijah mentioned earlier, the conditions around which we want the system to operate, right? We want to control it. We want it to be within that operating mode, right? So that is what we mean by a control system. The main function of any control system is to operate a system within certain boundaries, right? We don't, like I mentioned, you want to produce, say, chips. You want to produce chips, and then your process require that your oil that you use to fry is within 30 degrees Celsius, and then your oil is basically boiling at 100 degrees. You can imagine what the output will be. In fact, you are going to run at a loss, right? So now there are different categories of controlled operation, right? Because what you are producing is different. So you have discrete production, you have process. So discrete is when you are just basically running say you have packaging machines and you are just dropping something. Like the activities that are going on are just on and off, right? Just close this, drop this, and that. You understand? You are not varying, you are not measuring, you are not really measuring anything. So that's like a strictly discrete process, like a discrete operation, right? Why for process, which is very common in your food and beverage, then you are measuring, you are checking temperature, you are checking levels, you are doing all of that, right? You are not it's not just open a valve, close a valve, all of that. So that's when we say you have like a continuous process. You have like a continuous process. So now uh you can control a process using several means, right? You can control a process using several means. Some of us on this call would have maybe during the course of your final year project or maybe a class project in school would have worked with things like uh, mm, Raspberry Pi, Arduino boards, 80 mega, is it 5,000? I can't remember the number behind that guy anymore. So all of these devices, right? You would have worked with them, you would have programmed them using different languages. They are also systems that you can use to control a process or control anything, basically control an activity. So here I've listed the different types of control system. You have the single board computers, standalone, proportional, integral, derivative controllers. What this guy does is that if you are conversant with control theory, where we talk about PID, that is proportional integral derivative, where your proportion defines that, okay, when you have an error on your system, the change, the way your system responds to that error is proportional to the magnitude of that error. That's what you have with proportional in P and ID. Why for integral, I think integral looks at it in terms of like deviation in time, right? And no, derivative should be the deviation in time. I cannot remember that specifically at the moment like this. So you would have your k kp plus integral of I dt plus your derivative dt. You understand? So there are some controllers that are built. They were built specifically just for PID control, right? Just for PID control. So they look at the process variable, they check the feedback so that it can calculate for the error, and it just gives you the control variable to try to balance the system back to your desired set point. So those devices are built specifically for PID. And an example of that is this select PID 5. This is a temperature controller here functioning. So this guy here, you would have, sorry, this guy here, you would have you will set your PV, you will set your set points. You set your PV, you set your set points, and the device by itself will take control and be trying to regulate your temperature within the range of what you have. So we also have controllers that are built specifically for robot controls and all of that. That is what they were built for. I think I think one very important brand in that region, I think Fanuc and is it Kuka? I can't remember the name of that brand. Then you have controllers that are built. Can you all hear me, please? You have controller that are built for motion control. So what they do basically is motion control, right? So we also have programmable logic controllers, which is what brings us to the lecture we are having, right? Programmable logic controllers. These ones are built specifically for PLC. So in for industry, for industrial control. So many times in many trainings, people will ask that, oh, why can't we use embedded system? At least it will do so PLC logic controllers were built, designed for industry, taking into account environmental factors like vibration, the heat, and everything. They were built specifically for industry. And there are standards that specify all of that for that specify how those things are built. So we also have programmable automation controllers. We have distributed control systems. Distributed control systems too, you will find them you will you will find them in industry as well. Why they call it distributed control system is that unlike a PLC that most of the time its operation is always localized to a particular function or a particular equipment, DCS works in a way whereby you can have several controllers distributed across um, different units within maybe a single plant, right? And then everything is integrated through a database system whereby each controllers are communicating with each other through the database system, right? So all the controllers on the network have their own location that they that they interact with directly. However, they are all linked together, right? So even the programming and the configuration for DCS system. So majorly when you see somebody who works on DCS system, most of the time they won't say they are programming a DCS system. Most of the time you hear them say they are configuring because majorly that's what they do with DCS system. So you would have your different controllers shared across different locations within a plant, and all of them are they are they are linked through, say, a server or a database system somewhere where all of them dump their information with, so that every unit are interconnected, just like as if you are having a single PLC controlling the entire plant. However, they are distributed across, right? So we also have PC-based control, such that um, there are some controllers that you can install them, right? Like a normal software on your PLC. Yes, they are actually softwares. They are actually softwares, but they are installed on the PLC. So they kind of mimic an actual, right? An actual PLC system. So I think there is one Siemens also have with, it's called Win is it WinX or WinLC, right? So that controller is a software. It can be installed on a CP. What did I say? No, not CP. On a PC, sorry. Say a laptop, a desktop, you will install it on it. So when you are downloading into, so it's like a virtual, okay, let me say, it's like a virtual PLC on a PC, right? So you have those kind of control systems as well. So we also have embedded controllers, which I mentioned earlier, controllers like your Arduino, your Raspberry Pi, and all of that. Then safety PLCs. So some PLCs are built specifically for safety purpose. Specifically for safety purpose. I think Siemens have PLCs for safety. Uh, when you see their model numbers or their is it model number or part number, you would always see, I think, the letter F behind them. Those are Siemens safety PLC. While in Allen Bradley, majority of their safety PLC brand, they call them without logics. So they are safety PLC in terms of the way they have been built, the way they have been designed. So when you talk about a safety system, one thing that is paramount or one thing that is more important is the redundancy of the system. So what we mean by redundancy is that when a part of a system fails, there is another alternative or another path for the system to remain in operation without saying shutting down your operations. You understand? So what that means is that when we are talking about a safety PLC, there are chances that that PLC from the design would have, say, two processors or three processors or four processors, such that when one of the processors goes off, the other one takes immediate action after it and continue running the process. You understand? So that is how safety PLC operates, right? Are we all still following me? If you are following, just give me a thumbs up. All right. Thank you. So PLC did not just start, right? We didn't just get to this point where we are using PLC to control systems. No, it's the brain work of somebody. Somebody just came up and was like, how can we make this system easy? How can we make things easy for us? How can we operate the system without or okay, we've been doing things this way, right? We've been doing this way, we've been enjoying it this way, but then it looks cumbersome. How do we improve on what we have? So in 1913, Henry Ford introduced the moving assembly line, first large-scale process automation, right? So this is the guy that we can say, okay, the first automation process, like let us automate a plant, let us make a plant work without much human interaction. The first man that envisioned it, the first man that came up with the idea was Henry Ford. So uh, they designed their process and made it automated. Most likely they would have used hydraulics or even pneumatic system to control the process at that time. But then by 1947, when transistors became miniaturized, that is when the sizes of transistors was being reduced. It became something that was small. It wasn't as big as they were before. Then we started building electronic control systems, right? Like every other control system, like the uh, programmable automation controller that I mentioned earlier, the uh, these the special PID controllers, right? We're able to start building those little small control systems in electronic form. So, but then Richard Morley developed Modicom 084, which was the very first commercial PLC, right? And he did it while he was working with General Motors, right? So the idea of let's build an actual PLC, right, and make it commercial started with Modicom, right? Modicom, and the man behind it was Richard Morley, right? So then people started adapting to the use of PLC, and it became something that every other manufacturer has to started building something around it. Then SCADA system too emerged, enabling remote monitoring of geographically spread infrastructure by 1970, right? Then by 1990, we started having different industrial network protocols that you can use to connect your feed devices. You have Profibus, Profinet, Modbus, several like that. So today now in automation, we've gone beyond, okay, we are just programming a process with PLC. Now we are looking at how do we integrate Internet of Things? How do we bring AI into PLC programming? How do we do cloud computing such that you can have a server seated somewhere in in one European country and is controlling a machine somewhere in Nigeria here or in Uganda, anywhere in the world, right? Then we also have edge analytics. Edge analytics is that before you send out your data from the local site, every computation, every analytical decision that you need to make is made on the edge, like on site, before you transmit the data to wherever you are sending it to. Basically, Industry 4.0 has taken us to the point where you can be anywhere in the world, right? And okay, I've been in a plant where you are working directly with maybe an international OEM somewhere, and the person needs to access your system. So the person is far away, but he can still work on your system. Of course, with all of these have come with their own challenges, right? We all know that the world is a very, very special and funny place where every time when you develop something new for a good purpose, right? The bad boys will come and find a way to, you understand, find a way around it. So the challenge that has formed with this present age or this present time we are or stage we are with automation is cybersecurity. And so everywhere you start hearing things like cybersecurity. And if you are observant enough and you are seeing the trend of things on LinkedIn, you would have been seeing some guys of recent. I've been posting that I just completed this ISA cybersecurity training. I just became an ISA, that's 6224, is it 42 expert? You understand? So as the industry is growing, new challenges are coming, and we also need to also be on our feet such that we are following the trend and trying to improve on ourselves and look at where are the gaps and how do we fill these gaps. So in automation, basically, right? Uh, we have different stages of automation. There are different stages of automation, and which is what's brought about the automation pyramid. And this automation pyramid, the ISA, is specified by ISA 95, the ISA 95 standard, which is the enterprise control system integration. What this is basically just showing to us is that you can automate a process right from the field level down to the top management level, right? You can have everything automated and linked, integrated together. So according to this standard, right, uh, the automation process of an enterprise, now not just a plant, an enterprise, right, has been divided into 5 parts. But of course, when we are talking about computer, or let me say, when we are talking about computer mathematics generally, our numbering system starts from 0, not 1, right? So you have level 0, level 1, level 2, level 3, level 4. So what this pyramid is just telling us or showing to us is that the levels at which automation takes place in an enterprise, right? So we have level 0, and on level 0, we have our normal production process, which we call the field. That is the area where you have your machines, the machines you are controlling. You have your sensors, the sensors that you use to monitor the process. You understand? Then execute whatever program you have to run the output, which is your machineries that you have on the field. So this level is the level 0, field level. Field level. Then when you leave the field level, which is before we started thinking of how do we control, how do we automate, you already have all these, your instruments, yes, instruments like your pressure transmitter, temperature transmitter, your level transmitter. These are all field level devices. These are all field level devices. So, but then the only thing you can do with those guys is you can just take reading, right? So, but for us to now be able to control them, then we move to the next level, which is level 1, where we now mention, we call that level the control level, right? So on the control level, that's where you have things like your PLC, your DCS, right? Because this is where you perform the control of your process, your production process. This is the level where you carry out the control of your production process. So after your level one, then we talk about level two, the monitoring and supervising process. So you want to control a process, right? You can actually control a plant. You can build your automation process just to the control level and just end it there, right? What happens is that you become blind to what is actually going on. That is what happened. You become blind to what is actually going on your field, because the only thing you are seeing, yes, your devices are working the way you want them. You are switching this on, you are switching that on, but you cannot see when something is going wrong until it has gone wrong, right? So that is why on level two, then we now talk about monitoring and supervising, which is the supervisory level. And that's when we have SCADA and HMI. Now, your SCADA and HMI, they are basically screens, right? That you can sit down and you are looking at what is going on. You can have your alarms display or pop up on your HMI. You can have, if it is a SCADA system, you can collect data, save it, or log it on an SQL server somewhere or something. You understand? So you are collecting data as the system is operating. You are collecting data as the system is operating. Then the level three, the manufacturing and operation planning. So at this level, what you are doing is you are trying to bring your entire production process, right? So you can integrate an MES system, that's manufacturing execution system, such a way that when you are running your plants, right, you are not just monitoring the process itself now. Now you are taking logs of the raw material that come in, the output that goes out, right? And you are able to plan, okay, I've produced three batches of this particular product, right? And now this is what I have now. Then you can figure that, oh, so amount of waste has been generated. If I have this amount of waste, then it means somewhere along the line of my production process, something is going wrong, right? So at this level, it makes it easy to plan your production process. You understand? So there are also there are systems that which are called MES, that allows you to bring all this together, right? Which is on the level three. While level four, the business and logistics, which is the management level. So you have APR system like your SAP, uh, your SAP. So people build their EPR system on Microsoft. Is it Microsoft Dynamic Nav or something like that? Can't remember vividly. So at this point, you have integrated your entire process to the point that management can see, oh, they carried out maintenance on so unit or so plant at so date. It means that this machine is reaching its end of life, it's reaching its life's end of life cycle process. Then we need to replace this guy, right? And all of that. So everything becomes encompassed, integrated together, and linked. So when you have a plant or a facility that you have built from level zero to level four, then you can confidently say that you have built a total enterprise. Now, be mindful of the word enterprise, because your production stops, everything about production stops basically on level two, right? But when you have an enterprise system whereby even the top gun, the top guys, the top management system are also involved in the production system, the entire enterprise, you understand? Then you would have built from level zero to level four. From level zero to level four. Are you all still with me? So I mentioned earlier that today is all about talking, right? Just to build a background on what we we intend to on what we intend to do. Yes. So I believe what I've been saying since interest you guys. So I will leave this screen and quick check. So who can give me the number of the levels we have in the automation pyramid. Anyone who can mention the 5 levels, and then you state what each of those levels are called. Anyone on the call? Michael, Samuel. Okay. Can we hear from Michael, Samuel?
Okay, good evening, everyone.
Good evening, Michael.
Okay, thank you very much for this opportunity. Okay, starting from the first level, which is the level 0, also called the field level, where we have our field instruments, our tweeters, our sensors, the transmitters, the gauges, and the rest. Then that's the field level. Then moving on, we have the control level, which is level 1. Now, level 1
Okay.
has to do with the PLCs, our programmable logic controllers, and our distributed control systems, and the
Okay.
rest. Then moving on from there, we have the supervisory level, which is level 2. Now, level 2 has to do with our SCADA and our HMI, which helps us in monitoring. Yeah, you said in level
Okay.
2 that we are not seeing what we are doing, what's going on. If there should be a problem in level 2, we'll not see. But in level 3, because of the SCADA and the HMI, it helps us to know and see what is going on because we are monitoring it on the screen.
Yeah.
So that's the supervisory level. And moving to the next one, we have the planning level, which is level 3. Level 3 has to do with the manufacturing, MES, manufacturing execution system. So that
Yes.
has to do with the manufacturing, the processes, and moving on, we have the management level, which is the level 4, and the final level that has to do with the business, the logistics. That's where the people in charge, like the stakeholders and the rest, are seeing what's really going on. They are knowing when a system is due for change or for maintenance, and where it needs to be changed, it's changed. When it needs to be maintained, they are following up with the process. And that involves the enterprise resource planning. We mentioned the ERP and the rest. So
Yes.
that's the 5 levels of automation. Thank you.
And I mentioned that the ERP system like SAP, Microsoft Dynamic Nav, and all of that. Yeah.
Yeah.
Yeah. Thank you very much, Michael. So that shows that we have people in the call who are following. So in terms of control types, right? In terms of control types, we have relay-based control, we have PLC control, right? And I mentioned earlier when I was showing the history of automation, industrial automation, basically. I mentioned that Henry Ford was the first guy who came up with. And so after all of those period, different types of control system have come and gone. And we've had relay-based control system, which a lot of people who, in fact, these days, we still have systems that are still built on relay logic systems, right? We still have systems that are built on relay logic systems. Even the concepts behind PLC control also came from the idea of relay-based control system. So at the onset of industrial revolution, automation was relay-based, basically. These relays work on electromechanical principles, and we know what electromechanical principles are. So you run electricity or you run current through a magnetic field, and induction is induced. You understand all those principles, right? Induction is induced and it causes your contacts to close, your contacts to open. And based on that, um, people saw that they could build a system around it. However, that system was prone to failure, right? Due to mechanical parts moving, because they're basically mechanical parts. You have the coils that were moving to close, coil moving to open, were mechanical parts. And over time, the system is subjected to wear and tear because it is going, is open, it's making contact, and there's friction, right? So it becomes subjected to wear and tear, and then there is this frequent breakdown, failure due to that. Then we have programmable logic controller, which is what we have come here to learn. about, right? Which is what is running industrial, which is the backbone of industrial automation today. And these logic controllers are built as solid state devices, right? When we say solid state device, we know that these are electronic devices. These are electronic devices, and they are less prone to failure, unlike mechanical parts that friction here and there easily makes it to wear out, right? If you have a solid state device that is properly designed, right? I'm not talking about quick fix China component, right? Solid state devices that are well designed with the purpose that this is what we want to achieve, right? They are not prone, they are less prone to failure. Not that they won't fail, right? But not as much as a relay-based system would cause problem for you. So what is the major difference between relay control system? Like, why do we have to choose between any of these two? So this relay-based system, it relies heavily on hardwire circuits. And what do we mean by hardwire system? You have a lot of wiring going on in any relay-based platform, uh, panel, sorry. Any relay-based panel, you will have a lot of wire. You are passing one wire to connect. You understand? Because you need a cable to go to your A1, A2 contacts to make the coil energize and close. Then you now have your actual power supply line with its own cable. So you have a lot of cabling going on in relay system. And so at the end of the day, you see that the cost of running cables whenever you have a breakdown or a failure, the cost of even troubleshooting alone. And you know that in manufacturing industry, particularly when we talk about industries like fast moving consumer goods, time and money, you understand? The system breaks down and you are trying to troubleshoot 1 hour, 2 hours. The moment you check how much production you could have you could have made within that 1 hour or 2 hour, then you are looking at millions, billions of naira, if not even dollars, depending on whichever region you are. And so it becomes it is observed that the relay system is taxing, cumbersome, right? Firing of components alone was difficult. Then because you needed a lot of devices, you have your relays, your timer, contactors, counters, everything, trying to fit them into a panel. It becomes very bulky. So you are running one small production line and your control panel is bigger than even the production line itself. Doesn't make any sense, right? So these are one of the differences, like, and a disadvantage to the relay system, right? Modification and troubleshooting involve changing the wiring of components, which can be very time consuming. I've mentioned that earlier. But when you come to your PLC system, makes everything sweet, right? Because all you need to do is, even if you are making a change, you just need to modify. Just go to your software, tweak one or two things. If it is an input you are changing, you just change the addressing. If it is whatever you are doing, just do it basically from the software and you just download back into your programming system and you are fine. Everything is back to normal and you are back in operation like nothing happened, right? So another thing is that um PLCs are programmed with special languages which allow more complex operations in a compact form. So, take for instance, you want to run a PID control system and you're trying to use a relay system to control. If in fact thinking about it alone itself is complex to the mind already, right? It's complex, but you can easily fit this into a PLC program. When you say program, what is the definition of program? Program is set of instruction, right? And so when you know, in fact, from your formula for P and ID alone, you can think up something and use that mathematical formula to build an algorithm and design it into your PLC program. And you understand? And even now, life is even sweeter because when we maybe when we proceed with the program, you will see that you can actually get function blocks from whichever Siemens, whether it's Siemens, Rockwell, any brand you are using. You can just drag your instruction set, put it in your program, and you are done with programming complex operations like a P&ID control system, right? And so it makes it easy, makes it sweet, right? And when you are making changes to your system, you just reprogram. Like I said earlier, just reprogram. You are not doing anything serious, anything big in terms of physical wiring, right? Just change it. Even if it is, even if you will change wire, maybe you are just replacing terminals. Okay, this terminal is bad. You remove from this terminal and change it to another terminal. And when you do that, the next thing you just do is go to your program. Okay, I've changed this address here. This device is no longer on this point on the PLC terminal. It's here. So you just change it there and download, and you are good to go. Your plant is back up, right? You are operating again. So those are the major difference between them. So this guy PLC programming controller that we've been mentioning, what do we mean? What is this thing actually? Like, how does it even operate? What is the idea behind it, right? So a programmable logic controllers, these are solid state-based computers. Solid state-based computers using integrated circuits instead of electromechanical device to implement control functions. They are capable of storing instructions such as sequencing, timing, counting, arithmetic, data manipulation, and communication to control industrial processes, machines, and processes, right? So when we say it's a solid state based controllers, can somebody on the call tell me what a computer? Can somebody on the call tell me what a computer is? If I ask you what is a computer, how would you define a computer? Anyone on the call? Can you all hear me? Can you all hear me? Elijah again. Okay, Matthew Oluwaseyi. Matthew Oluwaseyi. Can you?
All right, good evening. Now. From my
Good
basic
evening.
understanding, I can say a computer
Please,
is
can you be
any
more
device.
audible?
Okay, I said a computer
Yes,
is any device that accepts
yes.
an input,
Okay,
process it, and give a certain output for an operation to
perfecto.
be.
Exactly. Right. So that is why we say the PLC controller is a computer because it functions majorly just like a computer. So it takes an input, it processes it based on the instructions that you would have downloaded into it or you have put into it, and it gives you an output, right? And so when you look at this diagram that I have here, you have your process or machine, right? So the activities are going on here. So say you have your sensor here, which is measuring the process. Something like your pressure transmitter is looking at the process, looking, okay, this thing is less than this percentage, and is sending it to your controller as an input. And the controller is looking at the instructions inside it that, I have been programmed that when this thing is less than or greater than, then this guy should open. Then it will just trigger the output, which is also a process or a machine as well, right? So it just triggers it. So basically, that's just what your PLC is all about as well. Your PLC is just a computer, but a computer built specifically built specifically for the industry, right? For the industry. The design, everything was built specifically for the industry, for industrial use. So that's why you don't see it's not something fancy, right? But it's an interesting thing to use. So I don't think I need to go deeply about all of this, right? So the first programmable controller design specification was developed by the Hydramatic Division of General Motors Corporation in 1968. I've mentioned this earlier before. The specifications require the solid-state system with computer flexibility to be able to do two things, right? Which is what I mentioned, that this PLC, when the idea of PLC came about, right, they had specific things that they wanted to achieve. Specific things that they wanted to achieve, which was that one, this device must be able to survive industrial environments. Any form of industrial environment, it must be able to survive in it. So, as I mentioned earlier, I mentioned that what are the adverse conditions you can have in an industrial environment? Vibration, harsh weather, right? You can have the PLC in a location where it is always constant heat. So you want to build a device. So compare that environment is always, the heat there is very, 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 very severe. The humidity is very, very crazy, right? Then you want to go and put something like your Arduino or Raspberry Pi board in that kind of environment. It will perform the control function you want it to perform, but definitely maybe in 1 month or 2 months, it will pack up because the design, the build was not, did not take into consideration that kind of environment. Now, another thing that was thought about was that any system we are building must be easily programmed and maintained by the plant engineers and technicians, right? Because what is the benefit of a system that you build and the people who are going to man it cannot work around it? There's no point. There's no point. And that was what brought about the major and the most common PLC language, which I think, okay, let me proceed with and the most common PLC language, which is called ladder programming, right? Which was built based on the principle. The idea of that programming style was built based on the principle of relay system. And the thinking at that time was that since these technicians can troubleshoot or they troubleshoot relay control system, if we build a PLC programming language that builds on that knowledge of PLC relay, it will be easy for technicians to go check the program and troubleshoot and find whatever their problem is and resolve the issue, right? So that was where the concept and the idea of ladder programming came from. So the basic idea was, let's build my system. Wow. Wow, Nigeria is about to happen to this class. Sorry, please. So that's the idea basically behind the specification when PLC was designed or built. Then the third one was that we also want a system that can easily be reusable. It can easily be reusable. So what do we mean by a system that can easily be reusable? So I build a system, right, using relay-based system, and I have, say, 25 timers there. And then maybe because of change in production plan, and I need to change some certain things in my control panel, and I don't need maybe 25 timers anymore. I need maybe just 10. Means 15 out of those then this are wasted because I don't need it anymore. But you have a PLC system and now you can easily adapt to another process. All you need to do is just download a fresh program into it. So your process has changed, fine. But the controlling platform behind it, nothing has changed. The only thing that changes is the software, the instruction that defines how the control process should go, how the system should function. That's the only thing that has changed. So you just rewrite your program, then just re-download it. So the PLC is reusable, makes it reusable. You can use it for several, you can just pick it from somewhere and just use it here. You are not trying to maybe modify anything just change the program, change the output. So it makes it reusable. So when they sat down and said, let us build a PLC system, these were the specification. These were the thoughts. This is the things that went into the thinking that, okay, this system we are building, this is how we want it to work. This is the specific behaviors. This is the specific do I call it parameters? No. Yeah, this is the specific behavior of how I want it to operate. And that was how they were built. That was how they were built. So where do we apply automation? Where do we apply automation? Sorry, I should have added some images to my slide so that it would have made it easier for us to grasp what we are saying. So we have conveyor systems. There might be people on the call that might have not seen a conveyor before, but you can easily just type in Google or YouTube and just watch a video of a conveyor system. Just type conveyor systems in industrial process or conveyor system in an industry. Can you still hear my voice? Because like I say, my voice only go down. So conveyor systems. So you can automate a conveyor system such that, okay, plant is running. The conveyor system, what are conveyor system? Transportation system. You are moving, say, a pallet, a carton from one point to the other. You use a convey. You use a conveyor to convey it from one point to the other. So you are not just moving cartons sometimes. So, for example, on the conveyor system, you have two different products moving on the system, but where they pack them or where the pallets that you fix them on are different because of you want to bag based on sizes or you want to bag based on batches, right? You can do some automation around your conveyor such that maybe when this package or when this carton gets to a particular point on the conveyor, a diverter should activate and push it to another conveyor that takes it directly to the point where that actual size of cartons are being arranged or stacked on a pallet, right? So these are areas where conveyor systems are applied. Then you have fillers for packaging and anyone who works in a brewery or a beverage processing plants, right? Say your Coke, your Fanta, they know what fillers are. So fillers are machines that you use to fill your products into a container, say a can, a bottle or something, right? So because you don't want to run short of whatever you are producing, you have to monitor, you have to automate your process because you ordinary eyes, wow.
So good evening. The tutor is trying to join back. We're experiencing a network issue, so please just hold on for a moment. So, while we wait for our tutor, okay, I think he's even here already. Hmm.
Hello, can we all hear me?
Yes, we can hear you loud and clear. Thank you.
Oh, okay. Sorry. So I came home from the office without coming with my charger, and even the alternative I had, there is no light safe. So sorry about that. So I was almost done with my slide for today. So I'll just try to conclude and would ask a few questions and end today's class. Sorry about the disruption. So um I was talking about the application areas in which you can apply automation in the industry. And I mentioned filler, your labeler. Lekon, did I send the slides to you? If you have the slide, can you just help me share and I will just follow from your screen as well. So we have the filler, we have wastes, you can apply automation in a warehouse, right? Majority of Amazon's warehouse across the globe runs on automation. So you have this system that they use to pick products from the rack, take it to the point where those who will pack it and then send it out for delivery. So all of these different processes can actually be automated. So we might be thinking that where yes, you can't see my screen because my screen is dead. You can't see my screen because my screen is dead. Yes, sorry about that. Apologies. So sorry, that's okay. So for you might be thinking that where can I come in? What area or what fields can I come in industrial automation process, right? You can be thinking that okay, what can I do? What can I do? So the fields or the position or roles in industrial automation that you can work in. All of them is PLC programming, right? So you can work as a programmer. You can function as a programmer whereby you write the codes, you pick up any control philosophy that might be provided by your clients or the end user. And based on the logic, the way their process works or they want it to work, you would come up with the program, the instructions that would run the system, right? Come up with the instruction or program that will run the system. Another area of field where you can function in is you can work as you can also function as a an instrumentation engineer, a control and instrumentation engineer, right? So you are playing basically in the region of how does the field instrument interacts with the process, right? You are calibrating the system to ensure accuracy of your system, right? Those are fields in industrial automation, right? Another area is you can work as a program designer, right? And in fact, these days I do tell people that a SCADA or HMI design engineer is basically a UI UX design engineer because you are building a system, you want to build a system that people can interact with, right? You want to build a system that people can easily interact with. So, and these days, when we talk about fields or we talk about subject matters such as design thinking, so when you are designing whatever you are designing, you're also thinking about the operator that will run the system, right? So you want to build an interface that the person is able to navigate, right? Is able to navigate through without error, without staring at the screen and is wondering what next will I press after I have pressed it. Or the person is seeing an alarm and he doesn't know what the alarm means, right? So SCADA designer is also one area, right? Of course, if you are going to play in the industrial automation field in Nigeria or basically within Africa, you are most likely going to be all of these things. You are most likely going to be all of these things. I can tell you that for sure, right? So another more recent field is cybersecurity, like I explained, right? You can play within the OT. OT means operation technology. OT, OT cybersecurity. So there's a slight difference between OT and IT. So OT is your operations technology, that is the process, the production floor, that's the operation floor, right? So the cybersecurity that deals with the protection of infrastructures that run the operation, right? So even when you look at the automation pyramid that I shared earlier on, your IT basically starts from your level 3. So when you integrate IT and OT, that's when you have your full enterprise control, right? So, but within the scope of automation these days, we also have the cybersecurity role that deals with operation technology, right? I will maybe later on I will share the Purdue model with us. The Purdue model simply just shows us the level of the security levels in automation. The security levels in automation. That is how you separate your different security level from the control level to the supervisory level. Then you put in your demilitarized zone, right? That cuts off, because when you are designing for cybersecurity, you are trying to build a system whereby your OT platform is secure, right? It's protected from whatever happens on the IT side, because you don't want operation to stop. You don't want operation to stop. So the Purdue model tells you where you put your firewalls, say if you are using a VPN and all of that. So there's also the role of cyber security expert, right? So then what knowledge do I need to have? What knowledge do I need to have to play in the automation field? I would say first and foremost, and very, very important, you need to know how electrical system works. And I believe that is why the organizers of this program first took us through electrical panel designs, right? You need to know how electrical system works, because the knowledge, the basic principles of automation, control system, many of it lies in how electricity move around the system. Even the relay logic system, it's basically you are using electricity to control, right? You are turning on a relay, you are turning it off. So you need to understand your wiring is very important. You need to know how you wire a system. It's very important as well. Those are knowledge that would help you, because at times, in fact, I tell people many of the time, when you write a software program, as long as nobody modifies it, you most likely will not have a problem with your software, except your software was not built or was not properly written from the beginning, right? Except your program was not properly written from the beginning. Anything from that, the program will not modify itself, right? So it's either somebody goes there and make a change, and if nobody goes there to make a change, then most likely your problem is from the field, or it might be a communication error. But most likely the software is the last thing to fail. So for you to troubleshoot a problem, troubleshoot a problem, you need to understand how these wires are being linked, how these systems are being linked together, whether for communication purpose or for signaling purpose. So you need to understand the electrical system. You need to understand process, right? So you need to have process knowledge. So you are going to be an automation engineer in a chemical plant. You need to know how those chemicals interact. If this one mix with this and this one mix with this is the reaction. Uh, if we have chemical engineers on the call, maybe this and this will cause effervescence, this and this will cause this, all of those things. You need to understand how those processes actually interact because it is in knowing how the process interact. That is how you know how to build controls around them, how to build safety controls around them, right? So you need to understand how process works as well. You need to understand how process works. You also need to know things about piping and instruments, right? You need to know things about instruments basically because your instruments is your eyes. I call instrument, I call them the eyes in automation because they are the ones on the field that sees the things you need to see, the things you need to measure. Without your instruments, you don't have any means or any way of collecting data, of collecting information about what is going on the field and sending it to the PLC to work on, to execute the program and give you an output, right? So you need to have an understanding, the principle behind the operation of your instrument. It is very, very important. It is very, very important. So it is very, very important. So basically, these are the major knowledge you need to gain. These are the major knowledge you need to gain. So yes, I have mentioned before that my screen has gone off and I don't have a means of turning it on back. So I am not sharing my screen at the moment. Apologies for that, right? Apologies for that. I am very, very sorry for that. So I think we can take questions. We can take questions so that we can um, end the call for today. We can take questions. I
So, Mr. Benga, thank you
Yes.
for the section. But before the question and answer, I would like us to take the
Yes.
attendance first. So after the attendance, then we can go to the
Okay.
question and answer and then close it.
Okay. Okay.
Yes.
Thank you.
So the code will be in the chat in the next 1 minute. And as we all know, the code expires. It's not that you log in and then you say you can't use the code or something and all of that. Please, once you drop the code, make sure you use it on your portal to mark attendance and nobody should come to anybody's DM. Thank you very much.
Lekon, how many minutes is for the attendance? Lekon, can you hear
So
me?
the attendance will be open for 1 hour, but for taking attendance here, we just need like 10 minutes break from you. Just 10 minutes. So we'll be back
Okay.
in 9:37. So people can just
Okay.
switch tab and all of that.
Okay.
Thank you.
All right.
So people on YouTube, you get the code now also, please. Just take him. So, Mr. Benga, I think we can all come back now and then have the last part of the session. Let's take the question and answer part, and I think we can close the session afterwards. Thank you.
Okay. So we can just move to the question and answer. So I think I have two questions in the chat already. First question says, as a beginner, I'm coming, trying to get the question back again. I can't see the person's question anymore. So I'll just take Clement's question. And his question is, why is it that majority of times technicians on the platform floor always would call on engineer to check his or her programs when there is an issue? I don't know how to answer that question because it all comes to how much knowledge or understanding the technicians have of the process, right? And maybe how much their troubleshooting skills is, how strong they are in terms of troubleshooting a problem. That's the reason why a technician will call an engineer, at least to the best of my knowledge. And then technicians in different industry might mean different things, right? So people will refer to their operators as technician. And some operators in some industries, they believe their job is just to start and stop a machine. So once the machine coughs, it's none of their business anymore. That is the understanding that they have, right? So it then takes an individual, right, to want to do more or to want to, to be exceptional, right, to exceed what is expected of him. Then such a person can work on himself, improve himself, and try to understand beyond his job of let me start or let me stop a process, right? And if the definition of a technician is just maybe say a maintenance technician, so he goes to the line, he sees that a sensor is bad, and his job is just to replace it, and that is what is wired into his mind, or that is what he believes his job is. He will not care about let me design or let me write a program or let me even look at how this HMI was designed. Right? He feels like his job is just to locate a bad sensor and just replace it. So that is not that is about the individuals. That is about people, right? So it's not something like there's no straight answer. So it is how the system is, maybe this how the system is designed or how the individuals see their job. So a lot of people will say, oh, this is my job description and that is what I will do. And some organizations also are like that they frown against you going beyond your job description. So if anything goes spoiled or go bad, they will say, why did you do beyond what you were supposed to do? So it's just about people and systems or where you are working at. Know what is expected of you. And if you need to do or exceed expectation, then you will build beyond what you are doing. So there is no straight answer to that. There's no straight answer to that. I think the question I saw earlier, I don't know, I can't see it anymore. The person said that as a beginner, which of those roles in automation should you start from? So if you ask me that question, I will throw it back to you that what role do you want to take on, right? And I remember I mentioned during the call, I said, if you are in Africa or you are in Nigeria and you want to practice automation, please just build a knowledge base in instruments, build a knowledge base in programming, build a knowledge base in HMI design, because you will most likely do everything. You will most likely do everything. So where do you start from? Where you need to start from in automation, like I said, you need to understand how electrical systems work. You need to understand how electrical system work. I think I will do something for us. Maybe by tomorrow, there is a book that I used to recommend to people. Anybody who has sat in a training I have facilitated before, I send that document to them. How was it? What's the title of this book? It's about PLC theory, right? You need to understand how a PLC works. The architecture of a PLC is very, very important, right? So many of the things we will take in module 2 and 3 will build on those core theories of how the PLC is designed, the architecture behind it, right? That makes it function the way it functions, right? So I would share that book on the WhatsApp group, maybe later tomorrow, because I will need to search for it from my archive. So I used to share that book with people. Trust me, if you can go through that textbook from chapter 1 to say chapter 8, trust me, you would help yourself in building a very solid foundation on PLC system, right? Because it's PLC programming is not just about building or writing your logic program, right? You need to understand how it works, how the PLC interacts internally and externally. Yes, so those are things you need to know. So I would share the textbook on the WhatsApp group by tomorrow. Yes, I will share it tomorrow on the WhatsApp group. So do we have anybody on the call with a question?
I think Olugua Caleb. I'm sorry for the pronunciation though. I think he has a question, so I'm asking him to unmute now.
Caleb's hand has been raised from the beginning of the
Caleb,
call. Caleb, do you have
Yeah,
a question?
yes, I do. Good evening. Am
All
I
right.
audible?
Okay. Yes, you are. I can hear you.
Yeah, just to be clear about the software we are going to use. You
Yes.
said Studio 5000, right?
Yes.
And you said you sent it on a drive to the group. I've been looking for it. I don't know, probably the network was a bit bad here when we were saying this, so I'm not really sure. I have not been able to access that drive on the group. So I would appreciate if you can send them. And we were asked to install TIA Portal version 17 too. At what point are we
Yes.
going to, because you mentioned they're starting with Allen Bradley, they're moving on to Rockwell. So at what point are we going to touch Siemens too?
Okay. So, Caleb, we are starting with Siemens, not Rockwell. Do you get that? Hello, Caleb, do you get that? We are starting with Siemens, not Rockwell. Now, Rockwell is Allen Bradley, the company that's the OEM that manufacture Allen Bradley is Rockwell Automations. Their PLC brand name is Allen Bradley. Do you get that? So when you say Rockwell system, Rockwell and Allen Bradley, you are still mentioning the same thing. The PLC brand name is Allen Bradley, built, manufactured, or produced by Rockwell Automations. So I think that is clear. I've seen your thumbs up. Any other person with a question? Somebody said his TIA is failing. So I don't know. You would need to, I think there is a video that was shared on how to go about, was it for the E-plan or for, okay, I think the videos that were shared so what's the problem? Can the person unmute? What's the problem with your TIA portal? Then I need to say this very clearly, actually. You see, automation problems that you might face when you come into automation field, 20% of your problem, 20% of your problem is you writing your program. 80% of your problem will be you navigating things that are not related with the software or the program you are writing. One of it is installation of the softwares you use. One of it is installation of the software you use. So you need to be very, very good at navigating problems with your system. You need to be very, very good with navigating problems with your system. 20% is your logic. In fact, I used to tell people that anybody can write a logic program. I tell people that if you understand logic gates and or if not, all of that, you can easily write a program. So majority of your problem will not come from your programming. Majority of your problem will come from navigating, because you can get to a plant. Say, for example, you get to a plant, you have version 17 on your laptop, right? And then you get to the plant and the plant is already running on version 18 or 19. You might not be able to upload a backup from the PLC running on the plant because the program, software you're having is not forward compatible. Do you understand what I mean? It is not forward compatible. That is, a lesser version of software would not take backup from a PLC with a firmware already running on an higher version. So on that plant there and there, you must find a way to quickly install the version that you can work with. And so you would have to navigate all the shenanigans that might come with your system, firewall protection, one driver has not activated and all of that. Navigate through, maybe you want to set an IP for your PC and all of that. You need to understand those things. Many of your problem will be that. In fact, you can spend 2 or 3 days trying to navigate that and you have not even done your actual work. So you need to be very, very good in terms of IT knowledge. And I think I should have mentioned that also in the knowledge you need. So you need to be able to navigate. I said the person should tell me what his problem is with his TIA, but he has not mentioned anything. So if you have a problem with TIA installation, you need to find what your problem is. You need to find what your problem is and work around it. One thing is this: most of the time when you are trying to install, your PC would pop, say, an error message. One thing I used to do, this is my own secret that I will share with you, right? Technology is your friend and things are easy these days. You can simply just use Google Lens to take a picture of the error message that popped out. And Google Lens will just search for you. It will even give you an AI overview of what the problem is and possibly even point out possible steps and procedures to take to correct the problem, right? So as you are working, you should also be thinking of possible tools that you can use to solve problems that you might come across. Like I said, majority of your problem might not come from how to write your program. Majority of your problem might come from how to even install, how to find a broken wire or broken cable somewhere, right? So who else has a question for us? Yes. So the AI overview is not to solve your problem for you. Like we say, people will say AI is not here to take your job. But the people who know or learn how to work with AI, right? People who know or learn how to work with AI will dominate the field, right? Those who have chosen to neglect AI would not. I said earlier on the call, this person said in the message you send, there are two different links. Yes, I said earlier on the call that you need to download both files. You need to download both files. One of that file is holding your Logix designer. One is holding view designer, and both are needed for your Studio 5000 to run. Logix designer is for PLC programming. View designer is for HMI design. Please throw more light on DCS and PLC. If you were on the call from the beginning, I mentioned that your PLC most likely is a localized control system. A localized control system. That is, it's controlling a specific operation, a specific unit of operation. Why for your DCS, you have distributed control. So you have several units or several equipment or several different locations on a plant, right? There are different controllers controlling each of those processes. However, there is a network that links all those distributed controllers and brings the information exchange into something like a database system that allows each of those distributed controllers to communicate with each other and link up together. That is what a DCS is majorly about. So it is more or less like you are having several controllers distributed across a plant, right? And majority of DCS programmers or DCS and this will tell you that they won't say they are programming a DCS system, they will say they are configuring the DCS system. And the major language in DCS programming is function block diagram. When we get to when we move forward on the training on PLC programming, we would see the languages, the programming languages that are available in programming PLC based on the ISA standard, ISA 61131. Somebody said, can I be unmuted to ask my question? Lekon, can we unmute this person? Let's quickly take his question, and that would end the call. Difference between PLC and HMI. It shows that you were not following on our class. PLC, I mentioned that on the automation pyramid, based on ISA 95, enterprise control integration, you have 5 levels on the control pyramid. On your 5 levels, we have level 0, level 1, level 2, level 3, level 4. Your level 1 is where you have your control system, and your control system is your PLC or your DCS, because those are the devices that perform the control itself. Then I mentioned that on level 2, which is the 3rd level, you have your supervisory system or your supervisory unit, which is your SCADA or your HMI. So just like we said, PLC is localized, right, in control units, while DCS is distributed. Same thing, your HMI is a localized human machine interface, right? So that is the interface that you use to see what is going on your plant, to monitor your plant, at the same time control your plant. That is, you can send in information from your HMI. You can operate your system from your HMI, but your PLC is the guy that does the actual control. So you can send instruction to the PLC from your HMI. That's supervisory and monitoring. You can monitor from the HMI. You can send in commands to the PLC from your HMI. So there is no difference. Like they are not on the same listing. So they work hand in hand.
So, Mr. Gbenga,
Yes.
I think because of time and it's late already,
Okay.
we would address all other questions from the group.
From the
So
group, all
Mr.
right.
Gbenga will be on the group, and if you have any other question, you can drop it there. Sorry, we could not unmute some people to ask their question and all of that. So please let everybody go back. What you've jotted. The video is also on YouTube. Go back, watch the video again. So to avoid the instructor answering repeated questions, so you don't ask the same question as this person have asked before. So you can watch the video, understand what he's trying to pass across, and after that, if you now have anything that is not clear, you can come to the group and ask your question and all of that. So thank you very much for your time, and have a great. So concerning the project, let us all know just a quick one that the project submission is closing on Friday. So on the 15th is the closure date for the project, and I'm seeing that some people are active already. Some people are asking questions in my DM, which I would not answer if you're asking me how to go about your project. But if you're asking how to find some component that will help you in your project, I'm open to answering that. But how to do it, or sir, is it okay or this? I don't think I'm privileged to answer that question. So we understand each other now. Thank you very much for your time, and have a great night rest.
So
Thank
a
you.
quick one,
Okay.
quick one. This person said that we should reshare the drive link. Please tell
So
him
on the
Adeleke,
group, we've sent it on the group already. Abi, is it not the one for the PLC?
the group has been pinned. The drive link is pinned on the WhatsApp group.
Yes, yes.
On the PLC programming group, you would see the link there. On the PLC programming group, you would see it there. All right, everyone, have a good night rest, and thank you for joining the class.
So, and if you have any question how to install, if it's not going through and all of that, you can ask on the group also. There are always people there ready to help you out.
Please, sorry, Leko, please
Yes,
be sure that you are on the PLC programming group. Saying it is not, I personally pinned it there. I have dropped the link myself on Monday and I pinned it on the group. So if you are not seeing the link, it means you are not on the PLC programming group. It means you are not on the PLC programming group. All right, Lekon, good night. Good night, everyone.
Thank you. Good night. Can end it now.